Let me check.
All good.
Where is that auto-tune voice? I think we are go.
Yeah, I think perhaps we should wait a few more minutes until a lot more people join, then we can send a link.
I'm going to make some scripts to the edits to my scripts right before the presentation starts.
Okay, so we'll start at maybe 7:03. Let's give it 3 more minutes. Yeah, so this recording will be posted on YouTube, and I'll also share the link in the Discord as well. Okay, it seems like we're all ready. So hi guys, today we're gonna go over the midterm of 2021 in the ITI 1121 class from last year. So this is the midterm that I and Glenn took. So where do you guys get this PDF? Well, it's on the Google Drive link, which I will share in the chat right now. So make sure you go into this Google Drive link and download this PDF, as well as the midterm. This is the one that you guys will do. So just download this one. And once you guys finish downloading, I'll give you guys 2 minutes for this one. Then we will go over the solution.
Notably, since I'll be covering Q1, I uploaded my own solution as well, and you can find the files within. But I'll also have everything up on screen. I'll be referring to it constantly, so it is optional.
Yeah, if you guys have any questions or if the Google Drive link doesn't work, just let me know. Just turn on your mic and ask.
Feel free to ask questions in the chat too, because I will be watching.
That's what she said.
So I see some people just joined, and I don't think they will be able to see the chat because you guys just joined. So what we're doing right now is we're just downloading the like the midterm in the Google Drive link. So this midterm is it. Okay, and I think time is up. So we'll go over the first question right now.
So I guess I'll be doing the first question, and so Welcome to question 1. This question seemed simple until I tried to explain it, at which point I realized that it tests several things. So it's going to test your general Java knowledge of the object class as well as method overriding. And 1.2 tests interfaces, whether you know the difference between shallow and deep copying, the difference between double equal signs and dot equals, and whether you realize that the interface provided to you is meant to be casted from. And all of these concepts are related to object-oriented programming. So with that, let's take a look at question 1.1. So the first thing you need to know is that every class in existence in Java secretly inherits from the class object. This is not something you need to write yourself. And that the class object happens to have a public method .equals in it that takes another object and returns a Boolean value. This is just information you have to pick up with experience. The question doesn't really give it to you. But with that, we can already implement equals in classes A and B, so let us take a look. Now, so here, if we take a look at equals in class A, we see that we have the override tag. This is not strictly necessary. What this does is if you were to try to compile our code and this doesn't actually override something, your compiler will tell you. So I'm putting this here for clarity. And this is the signature of equals found in the object class, and it takes another object and returns a Boolean equals. To implement this, you have to check first, is the object null? Because if it's null, you know that it can't be equal to this, because this, if you're able to call this method, the thing you're calling it on is not null. And then we check that, make sure that there's an instance of A, because if it's not an instance of A, it's clearly not equal to this, so we return false. And now that we know that the object we passed in definitely is an instance of this class, we can actually cast it into an instance of this class. And here we can find the comparisons. We make sure that the A in this class is equal to the integer A in the other class. We do the same thing with B and C. And here, now we verified that this other is an instance of A, and all three of these match. Therefore, we return true. And this method works as intended. It compares the values within the class. Otherwise, it will return false. And then we do the same thing in our class B. And here, we're basically making sure that the B we're comparing to has the same A1 and A2 as the B in class that we called this from. And we basically repeat the procedure here, except we use the method we wrote in the A class to compare, make sure that everything within these is equal as well. And that is how we implement .equals. So this is question 1.1 done. We have already implemented equals, and what it checks is to make sure that A and B are, the contents of A and B are equal, the contents of the things you're comparing are equal. Second part, you need to implement the interface deep copyable. So this tests your knowledge of interfaces and copying. So I'll go over a simple explanation of copying first. So every object in Java ever, so anything that is constructed with a new keyword is secretly a pointer to a bunch of data. So for example, we can see this in the code provided to us actually. So B is an object. You can consider B1 as the pointer to this collection of data, which just floats about somewhere. And you can think of the name of the variable as the pointer, and the data it points to as what you pass in the constructor. So if I were to do something funky and say B1 is equal to B2, all of this data that B1 used to hold just gets thrown out the window, and we've basically done a shallow copy of B2 into B1. These pointers are now the same. They both aim at the same set of data. If you were to try to do something like B1 double equals sign B2, this would give you true. What a deep copy is they don't have the same pointer, but they have the same contents. So if we initialized B2 with all the parameters that we gave that happen to be in B1, you would now have a deep copy of B1 and B2, and that is what .equals compares. So if B2 had all of the stuff as the same stuff as B1, B2 .equals 1 would return true. That is your deep copy for you. This post explained it much better than whatever the addendum was at the bottom of this file. So this is, I like this more. Okay, going back to question 2. Now that we have now that we covered the differences between shallow and deep copying, we have to figure out how to do that with the interface. So if we take a look at the interface, deep copyable, any class that implements this must have a public function that returns a deep copy of itself in the form of a deep copyable data type. So in other words, further manipulation requires casting. Blockdot made a good infographic for how this works. So basically, there's two types of casts in Java, and both of them serve the purpose of letting you use one data type as if it were another. In our case, we want to figure out how to use deep copyable as a wrapper for either class A or class B. So the first type of casting is upcasting, and Java does it implicitly, and there's an example of it here, and we'll see more in the question. The second is downcasting, and again, I think it'll be best explained when we take a look at our implementation. So with that, let's see how it worked with the interface, as well as examine how it interacts with testdeepcopy.java, because we do have some examples of the both there. So for A, we know that we say class A implements deep copyable. This is just syntax to say, okay, we're going to use this interface. What is this interface of? It has this method. And even though this doesn't have an access modifier in it, for interfaces specifically, if you don't have a modifier before a method, it's secretly public. This information isn't given to you. You're just expected to know it, just like how you're expected to know the class object happens to have a equals method in it. So here we overwrite that, we implement it, and here we just basically return a new object class A that has all of the values in this one. So this is a deep copy, as I've mentioned before. And we don't have to say return deep copyable A. We don't have the cast that we've made here because upcasts are implicit. That is just something Java does for you. We also have to implement that method in B, and here we do what it does what it says on the tin. So it gives you a deep copyable, it gives you a copy of B in the form of a deep copyable with an upcast. So we basically say, we want a deep copy of A, we want to initialize B, so we're calling this constructor with a deep copy of the first A1 and a deep copy of A2. And here we're doing a little downcast to make sure that the deep copyable that this would normally return gets casted to A, which gets passed in here, and gets set in the new version of B. So now we have methods deep copy in A and B that return all of the data in the form of deep copyable. And now we have let's take a look at how this class calls them. So we can go through these one by one now, I think. So system.out.println does b1 equals b2, and this is supposed to print out false. And why does it print out false? It's because the contents of b1 does not equal the contents of b2. I think this one is pretty straightforward. And now we have the test b1 dot equals b1 dot deep copy. So now we're going to make, in other words, this creates a deep copy of b1 that has all of this data, but not the same pointer. But since we're calling dot equals on it, we're making sure that the a's within here and the numbers within the A are all the exact same. And since that's what deep copy does, this returns true. The next one checks if b1 is equal to the deep copy of b1, and this is false because, as I mentioned before, because this creates a deep copy, you now have two separate pointers that point to the same set of data, and the double equal signs compares the pointers. They are different. That returns false. That is expected. And now we have b1.getA1.equals, and we cast something to b, and that is the deep copy of b1.getA1, and this should equal to true. So there's a lot going on here. So first thing we have to realize that b1.getA1, all this does is we are now comparing A1. So we're going to be comparing something of the type A. What are we comparing? Well, we're first taking a deep copy of B. So in other words, we create a new B that happens to have A1 and A2, the same thing as the B we passed in, .getA1. And then because it's the same thing we passed in, we now have two different pointers to the class A that happen to have the same set of data called .equals that compares the data instead of comparing the pointers. That returns true, behaving as expected. Last one, b1.getA1 double equal sign, the same thing as before. But since deep copy gives you a copy of B that has the same values and not the same pointer, the double equal sign returns false, and that would also behave as expected. So we see that everything matches here, and that is question 1 in a nutshell. I think I went a bit fast, so if anyone has any questions or clarifications, please let me know. If not, I will hand it back to Guokda for question 2.
Okay, well, first of all, are there any questions about question 1.1 and question 1.2? if you guys are finished, then we can, yeah, okay. So looks like in the chat, people say that it's all good. So we should move on to the next question. I'm gonna share my screen. Okay, can you guys see my screen? Okay. So question 2 is worth 10 marks. And I think that one of the most important skills to be successful on the midterm is to be able to read quickly, right? So I'm going to give you guys some time to read this page up until this one. Okay, so from page 4 and then page 5. So just read these 2 pages. And after 2 minutes, we're going to go over the solution. Okay, I was muted for a second there, but what I was saying is that it's okay if you haven't finished reading. I'm just going to summarize what they mean. So if you look at here, they have a stack, right? We have an integer stack, and this is the bottom of the stack, and this is the top of the stack. So what they want you to do is remove consecutive duplicates. So you see here, right? You see there are 2 duplicates of number 2. And here there's only 1, 2. So you just remove the duplicates. So you get 0, 1, 2, 3, 4. And then the original stack has to stay the same. So basically what you're doing is you're creating 2 stacks. The first one you're keeping the same, then you copy into the second stack, and then you remove the duplicates. So that's basically what they want you to do. And I'm going to draw some diagrams. Hopefully it can simplify the algorithm. So this is my solution. I will create 3 stacks. So we have this stack called the original. Then we have this one called reversed. And then we have this one called result. And let's say the original stack has something like 2, 1, 1, 0, right? The first step that we're going to do is we're going to pop this into these 2 stacks. So let me redraw this. We're going to pop this into these 2 stacks here. So we're going to get 2, 1, 1, 0. This is the same 0, 1, 1, 2. Okay. Do you guys understand? If you have any questions, feel free to ask. And then the third step is I'm going to bring this over to the original. So let me draw the third step. We bring it over here, so 2110. Then this stays the same. This one is 0112. And this one is gone because we popped it, right? So as you can see, the original stack has to stay the same. It cannot change because in the PDF they want it to stay the same, right? You cannot change it. It has to stay the same. Now the last and final step is we pop everything in here. We move to the result. Move to the result, but basically we are going to remove the duplicates at the same time. So we put 0 in here, and then the 0 is gone because we popped it. And then we put number 1 into here. Okay, so this one's gone. And then we put number 1 into here. We pop it, and then we see that this is number 1. There's already a number in there, and it's 1. So we just ignore that case, right? Because there's already 1 in there. And then finally we have 2. So we pop that into here, and that's gone. And this is your result. So that's it. That's basically the algorithm. Are there any questions before we start coding this? Okay, no questions. Awesome. Okay, and let's go over the code. So you might see that in the midterm, they give you this class, right? You have a class called, this one is a very long name, and then it extends the array stack. And the array stack extends the stack interface. And the stack interface has is empty, push, pop, and peek. So these are the functions that you can use. And then you have to add your code into the this function that returns a stack on its own. So let's draw the UML diagram. And I wish I've known this last year when I've taken it, but basically if you draw this diagram, then you can solve it a lot easier because you know the inheritance table, right? So all we have to do is just code this stack. So here is my solution. I created 3 stacks, the original, the reversed, and then the result. So 3 stacks. And then the first step is we're going to pop all the elements from the original into the reverse and the result. So basically we're going from here to here, right? So while original is not empty, while this is not empty, we're going to pop the first number. So we pop 2 into element, original.pop. We're going to take the first number out and store it in the element right here. And then we're going to push it into reverse and result. And then after this for loop finishes, this is what we have right there. Okay, if you need to type it in, I'll just give you guys some time. Now we're gonna go over the second loop, and it's quite simple. The second loop says that we have to pop all the elements from the result into the original. So basically, we take the let's see, we take this one, then we pop it back into the original, right? So you see that this one is empty afterwards, and the original has like the numbers that are not changed. So we just keep this the same afterwards. So basically, while the result is not empty, we pop it from the result into element, and then we're going to push it into the original. And that's the second for loop. And the last for loop, then the last for loop, and then that's it. The last for loop is we take all the numbers here and then we put it into here and removing the duplicates at the same time. So we pop all the elements from reversed into result, removing the duplicates. So while reverse is not empty, so while this is not empty, we're going to pop it from reverse and store it in element E. And then here we have the try statement. So if you guys, when you try something and you're afraid that it might throw an error, just use a try and catch method. So if the result peak is not equal to the element, basically what that means is let's say we pop number 2, right? We pop it and then we put it into here. And if we peek this one and the number 2 is already there, then we do nothing. We don't put it into here. So we don't put the number 2 into here. It just doesn't make sense, right? So if we see that this number is the same as this number, then we ignore it. So if it's not equal, then we put it into the result. And then here, basically what I'm saying is that for this one, why is there a try and catch statement? Well, that's because, let me get rid of this diagram. That's because the first time that you pop this into here, the first time you put number 2 into here, and then we peek from this stack, we peek from this one. There's no number in here. And in Java, that's going to throw an error. The peek is going to throw an error if it doesn't see any number in this stack. So if there's no number in here, it's going to throw an error, right? But we don't want it to throw an error. So if there is there's no number in this one, then just put it here and then pop that one, right? So basically, that's the code for the third for loop. And then that's it. Question 2 is done. So at this point, the midterm is over. We just went through all the questions. Now the floor is yours. If you guys have any questions, feel free to ask.
Try and catch. Do you have any questions about try and catch? No, maybe we should answer the second one first.
Yeah, we'll go over the. Okay, so the first question that I received in the chat is not sure if our professor wants us to use a try and catch statement at this point. Let's see. Let's read the document and see if it wants you to if you can use it. So here it says important restrictions for question 2. You cannot change the array stack. Basically, you can't change the array stack Java or stack file. You have to keep it the same. It doesn't say you cannot use try. It does not say you can use try and catch. So if it doesn't say, it means you can use it. So the question.
So are your midterms just multiple choice? And you don't have to worry about any data types? Okay, so there is code.
Okay, let's go on to the second question in the chat. I am just a little bit lost. Where is peek and push from again? Very good question. And I'm going to show you something again. Like I said, it's very important that you guys draw some diagrams when you get the code. So you see here, the uni variable, it's a very long name, I'm not going to say it, but this one extends from array stack, right? Basically, this class that we're on, it extends from the array stack. And now if we go here, the array stack has these functions, right? It has is empty, push. So that's why I fill it into this box. So we know what functions are there. And then this array stack extends from and it implements the stack interface. So it implements the stack interface. And after you have this diagram, it basically answers your question, which is where does push and pop come from? Well, it comes from these classes here. Okay, for try and catch, if on the midterm it says you cannot use try and catch, then don't use try and catch. But
I
on
think
the
they're
midterm,
asking whether
Yeah.
try and catch needs to be covered. So I remember from last year, I was not tested on exceptions until the final exam. I'm not sure if that is the case this year.
Yeah, so make sure
But
to
yeah,
ask.
either way, you still have to read the question. What I am doing right now is I'm browsing. Okay, cool. I'm browsing this website to see if there's any midterms or final exams worth covering for you guys. But I'm at a dilemma because none of the midterms I could find have any multiple choice questions. So if you'd like, I could go over some of the final exams that do have multiple choice. But most of these are
Wait, it's
covering
one catch.
data
Yeah.
structures, which I don't think are on the midterms yet. Oh, okay, I see. Yeah, in that case, mark that as right. You should follow the question. If it says don't use try catch, don't use try catch.
Okay, so someone has a question in the chat. It says, I don't think we have done stacks. Well, I mean, it was on the midterm last year, so I think you guys should ask the professor if stacks are going to be on the midterm. For our class, it was on the midterm. Okay, so Kevin asked, so just making sure I understand, it would read the catch statement first, right? Because the stack is initially empty. Okay, so what's going to happen is when you peek from a stack, when you peek from the stack, and let's say that this is empty, so let me erase this. It's going to throw an error, and when peek throws an error, then you know that the stack is empty, right? But you don't want your program to crash because of it. That's why you have the try and catch statement there. So my advice is just to go through this code and just do it on paper. It's only 3 while loops, and basically afterwards you will see what I mean by the try and catch statement. So Glenn, there are some like questions that you want to go through on your end. I'm going to stop sharing my screen.
I see two options. One is we do the midterm from 2020 live. Like I have not prepared anything for it. We will just go through the process together. The alternative is we can go through some multiple choice questions from 2018's final exam. I guess I'll share my screen so you can see what I'm talking about. So from my perspective, we can either take a look at question 1 from the 2020 midterm, or we can just go through this question, which happens to be multiple choice, and will probably be a lot faster than whatever this is. So what are you guys what are you guys thinking? I think both of these are equally good learning opportunities. Multiple choice? That's one vote for multiple choice. Are you go with MC? Oh. Magic square and the multiple choice are not the same. Okay, so I guess we can go over them. So let's do votes for square. In that case, sure. I am going to be doing this like without any prep whatsoever, so let's see. In this question, we develop a representation for a magic square. Its most basic form, a magic square is an n times n grid filled with numbers, etc., such that each row and each column, as well as two main diagonals, all have the same sum. Magic constant m, where m is equal to... Okay, so we'll just compute this when it comes to n is equal to 3, m is equal to 14. So this is 9 plus 1 times 3 divided by 2. And that is equal to 15. Yeah, sure. For this question, you must complete the implementation of class magic square on page 4. Just like in assignment 1, this uses a one-dimensional array to store the values of a grid. Why are you using a one-dimensional array to store the values of a grid? I'm going to assume that it's stored like 1, 2, 3, I mean 0, 1, 2, 3, 4, 5, 6, 7, 8, which to me is a bit cursed, but we'll work with that restriction. In the class declaration on page 4, declare 3 instance variables. Okay, I'm going to start coding. So that's because for me, instead of taking notes, I just write the code. Magic square.java. We do our basic things. That's magic square.
Can you zoom in a bit? It's kind of small on the screen.
Huh?
Can you zoom in into the code?
Oh, how do I? Oh yeah, sure. Like
Control and
this.
scroll up. Yeah.
Usually, one of the things that made me really fast at midterms is I actually have 2 monitors, so I don't have to work in a space this cramped, and because this feels awful. But if you have 2 monitors or like a second screen or a phone, it's really nice to be able to pull something up on the phone and be able to code like this. Let me just make sure I got the basic syntax right. Whoops. Okay, so that is working. Reference code on page 4. Whoa. Okay, so the main is in a different class. That is fine. And how we deal with that is, let's make a separate folder for this. You go in there and we will put a main. I'm pretty sure that on the midterm, they will actually provide this code for you. So you don't have to memorize any boiler. You shouldn't have to memorize too much boilerplate code. All of this stuff gets put in here. Oh my goodness. Thank you, PDFs. We'll fill that in later. Things like these that make me wonder if it's worth learning Colmat. Oh, all of this goes within the main function. Okay, that makes more sense. S2 is equal to new, and then, you know what? We'll just test out all these things from S1 first. Oh my goodness, why do I even bother? So I see a system.out println S1. That immediately tells me that I'm going to need to override toString in magic square. Because toString is another one of those methods that happens to be an object class that we're just supposed to know that is there and can be overwritten and gets printed when you do system.out println on pointer. Size, get constants, and is magic. So in other words, all of this stuff is very basic computational stuff. I don't know what constant does though, but everything else can just be calculated. You just kind of look at the code and you unga bunga, stick that formula in, call it a day. So magic square.java. Reference variable we use to designate a one-dimensional array of int values, store the values on the grid. How is S1 being constructed? What? Am I missing something? Oh, S1 is equal to the new magic square, and it puts the values in there. Okay, I'm not going insane. So now we know this magic square, it takes an integer array for a constructor, and now we can put that in here. Please stop me if you have any questions. And just for convenience sake, we are pretty sure we're going to need to store this within the class. So let's just declare that here. This dot values equals values. Wow. And now we have to implement, I don't know what you are. Get size. Get size is, well, I'm assuming get size is all magic squares will be to n by n. I guess size would just be the length of this array, but square root, right? So I guess we could put that in here. So size is equal to, and I forget the syntax for this, so I'm pretty sure it's in the Java math class. But there should be. If you don't allow to use an API and you have to do a coding question, I think that will almost never happen. So I think you should be allowed to access the docs. If not, well, some good classes to memorize are the math class and the string class. But you should have this stuff accessible. Square root. We have the square root for double. We don't have a square root for an integer, which means we are going to need to cast whatever comes out of this. This should give us the size. If values.nav is not divisible by 3, that is a problem, and I don't think it's going to happen unless unless the question specifies it. Let's just make sure that we have the size function working. You 80 squared. Cannot find. What is this? Am I not square root? Am I that? Am I that washed up? Have I not done Java in so long? Okay, get size. That is fair. We haven't done the get size yet, so public integer get size and then turn size. Technically, you don't even need to store this. You can just compute this dynamically, but I guess it wants the method. And we don't have these guys yet, so we get what is going on here. So first oh yeah, we're printing the size twice, so that is one mistake, but that is working. So this is n. It does print n correctly. What else do we need to implement? Constant. I've just been doing this stuff by accident. So reference to a variable used to designate a one-dimensional array of int values. We did that here. Variable to store the size of the grid represents both the numbers of rows and the number of columns in the magic square. We did that here. That is size. Store the magic constant. Oh yeah. I don't know if you guys have been taught about encapsulation yet, but all of these should be private, I think, because you have a getter. That means that these guys should be private. And might as well compute the magic constant here because we can. Equal to, what is this? Size times size plus 1 divided by 2. That should be it. And I'm guessing you can do public. Yeah. Basically, I think questions like these just hold you by the hand the whole way through. You just have to hop through a lot of hoops. It's giving you the equation, you plug in the equation, you call it a day. Turn magic constant. And now we can put this back. And yeah, that's 15. It matches what we got here. So that is part A done. Part B in the, oh my goodness. Class declaration on page 4, implement the constructor. So in other words, we did that just by looking at what the main was supposed to be. So we have that constructor here. Make sure that your implementation complies with the following guidelines, stores the value of the magic square specified by the parameter. We do that, yes. As illustrated by the test program. Oh, I missed some stuff on chat. Some PL tab for the, oh, I'm using Atom. So I don't think I'm using the same editor as yours, but I don't think this. What? Okay, you guys are right. Thank you for that. Huh. If I knew that when I was doing my midterms, that would have gone a lot faster. Thank you. Constructor stores the values, object the class magic square is not affected by subsequent changes to the, wait, what is this? Object the class magic squares is not affected by subsequent changes to the array values passed as an argument here, and you can assume that the value of the parameter will not be null and the given array forms a square. Okay, that is the longest way of saying this input will be valid I have ever read, but that's basically what it's saying. Value is going to be, you can put values in here. The constructor calculates and stores the size of the magic square. Yep, we do that here, where the size represents both the number of rows and number of columns. If you're not allowed to use mat.square root, you can write your own square root function that just loops from 0 all the way up until the multiple is greater than the number that you have. Square root is not a difficult function to write as long as you're allowed to do it in ON time, which you probably are, because you don't have to worry about that stuff until like data structures and algorithms. So if you need to write your own square root method, it's not the end of the world. Finally, you must compute and store the value of the magic constant. Wow, we also did that just by looking at the main program. So part C, 4 marks, implement the following 3 access methods. Get size, we did that already. Get constant, we did that already. Get value. 2-dimensional coordinates, where's the... You know what would have made this easier? If we had a 2-dimensional array, but I'm not one to judge. Sometimes on tests you have to hop through a lot of hoops, and this is one of those. Int row, int column, and I guess you just return the value of row times size plus column, right? You guys understand this, right? I think it works. If it doesn't work, I'm probably look like a clown right now, but I think it works because row basically does, well, it depends on how you're referring to, because like if you have row 0 and column 2, which I'm assuming is this one, I'm assuming it starts 0, you get 0 plus 2 and it gets here. If you go for row 1, column 1, then you do row times 3, so you're already taken up to here, and then column 1, you go up to here, and then that gets 5. So it works. You just think about it for a moment, and then you get what you need to code. And the helper method is magic diagonals. Turns true if and only if both terms, the sum of elements on the main diagonal and the main anti-diagonal are equal to the magic constant. Called by the method is magic. Not required to implement the other two methods. Called by is magic square. Is magic rows and is magic. Okay, cool. So again, it's making things easier for you. So public. Wait, it's a helper method. Does that mean that we can make this private? Yeah. But this is, if you see helper method, just know that it's probably either private or protected, because helper implies that it's doing something internally within the class and it's not going to get called by something outside of the class. So just stick a private on it. If it doesn't work, put a protected on it and see how it goes. Just don't make it public. Private bool is magic diagonals. And then I guess we just, for int I is equal to 0, I just basically want to iterate through, because I'm assuming we're going to like use the get value to get all of these values, check if they add up to n, and then get these values, check if they add up to the magic constant as well, and then return an AND of those two values that you get. And to do that, best way to do that is using get value. So I is less than size, I plus plus, and then let's just do sum a is equal to 0, sum a plus equals, what's the thing? The value of I, and then we, guess we can do sum b as well, and then sum b plus equals get value of, we're still going row by row, but now we're doing it in reverse. So I, and then size minus I. This works, right? I think this works. So now we just have to return sum a is equal to magic constant, and sum b equals magic constant, and yeah, that's our helper method. And I'm guessing, since this is a helper method, that means that there is a public method for is magic, and this just returns is magic diagonals. But in truth, it should also check the rows and columns. I don't know if we need to do that yet. Do we need to do that? You don't have to implement is magic rows and is magic. But do we have to implement is magic columns? I'm a bit confused, but this will. I guess we can implement both of those. I mean, we'll implement is magic columns as well. The shortcut was E, L, and then tab, and then you get to type whatever you want in there. I think I'm still typing out system.out, but I just had it like muscle memory, but that was the shortcut in response to the question. And now we just fix the syntax errors, cannot find symbol. I am coding way too much in C# these days. I'm still bane of working like 5 different programming languages, and then we check if this guy's magic. I'm assuming this guy's magic because that was what was provided to us. I'm guessing 315 false. Is this guy magic? 186357492. 1 plus 5 plus 9, that is 15. 6 plus 5 plus 4, that is also 15. You should be magic. So now we debug. And specifically, I think this is the method that is giving us trouble. I'm still doing that out of muscle memory. I like doing a few hashtags just to mark, hey, I want some information here. And that is such a cool shortcut. And this, well, basically let us make sure that the diagonals we're getting for sum A actually match. So let's see what we're getting. We're getting 152. That is 152. Wait, that's right. 152. Oh, wait. So this isn't a magic square. I'm being pranked. Okay. So if I wanted this magic square, then the values would be. So my output is correct. This just isn't a magic square. So let's put in the real thing. 816357492. This is a magic square. What? Still false. 852. That is 15. That should be equal. And then we have 654. Let's check the other one then, because the other one might be a bit dodgy. The sequence is not right for the first one. Well, that was the sequence that was given to me in the over here. So I put this in, and turns out that that's not a magic square. Let's check this. What are we getting? 379. We're getting. Whoa, you're not supposed to be there. 379. So something dodgy is definitely happening. So we're still getting the right column, and then we're doing. Row is. Wait. So I is the right row. And then with the column, because I know you want to go backwards, right? So if I is 0, you want to get this. Oh, there's a -1 here. I hate one-off errors because the only way you really get, and there we go, now it's fixed. It was a one-off error. And I suppose it helps if you draw it out, but you just have to think about it and honestly try adding in -1 if your intuition's telling you it's a one-off error. But I think that is magic done, or at least we verified that our diagnose things works. And let's go back to the control group. This we know is not a magic square. That true then should be false. Nice. I think that is this question done. So let's see. Oh, we have to print out the thing too? Okay, so that is what this, now we know what this one is. Now we know what the print S1 is. You don't want, we have to do with toString again. Public string, toString. The professors don't teach you this, but it's good form. That override thing. Or I do know about this shortcut. And I is equal to 0, I is less than, did I call it size? I called it size. I'm not a fan of using n and capital M for variable names because I think it's introducing clarity. It's reducing clarity when there already isn't that much clarity. Let's change all of these to J, and then system.out.print, no line, get value on J, plus, let me give it a little, oh, they use space. I usually like using tabs because it looks nicer when you have bigger values, but they use that, we use that. System some print line and another two string should work as well. Let's get rid of our debugging code. How could I select all edges at the same time? What I'm using is the Atom editor, and it has this cool feature that allows me to like control click to add more cursors. It's not, I don't use it that much, but it's very nice when I can. So that is just missing return statements. Right, you're a two string. Okay, for cared about performance, I would use a string builder, but this is a midterm. I don't think I'm going to lose marks if I just happen to do a bit of concatenation. String is equal to this, so string plus equals get value, etc. And then string plus equals a new line, and now we should have that last bit of the question. What? I forgot to return it. And now, yes, our output matches. Hallelujah. Switch it to this. Oh, wait. Right. They do the S2 thing. Okay, let's put in S2. Values 0 is equal to 8. Values 1 is equal to 1. And then S2 is equal to new magic square values. And then you do the print out of S1, and then we add another print line. We do a little up, up, boop, 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 boop. Why are you true? Why are you? Oh, okay. You need to deep copy the array in the constructor. I was wrong. This is what it meant when it had this giant paragraph. It wanted to deep copy the constructor. Let's deep copy the constructor. This dot values is equal to new int values. So I'm a bit stuck in my ways in that I always like having this name be the name of the thing you assign it to. So we have to be careful here with our this. So values.length returns that gets the value of this, but we're assigning it to our thing. And now we live through. Hooray. I is less than I plus plus this dot value is dot. This is why I like doing multiple choice more because it doesn't take this long to do a question. I hope your people are learning things, I guess. But yeah, I think cool. The outputs finally match. We're good. Technically, you can get rid of the last new line if you really cared about this, but that is the most tiny thing to do. So our outputs match, and this what? So there was a template code. Okay, there you go. So you don't have to memorize any of that stuff. You're given this stuff. Okay, that's what they meant when they said you don't have to implement is magic rows and is magic columns, because that's also basically given to you, and you can just assume that you have it. So yeah, that's the question, honestly. Are there any questions about the magic square question? I don't feel like uploading this, so I'm going to post my entire code in the chat if Zoom allows me to. Zoom does not allow me to. That is understandable, I think. Am I really not allowed to? Okay, I guess Zoom does have a character limit and I've hit it. Here's everything up to line 29. Here's the rest. And if there is something someone else would like to have covered, I will hand it over to Gorgda because I have been at this for long enough.
Yep, can you hear me?
Here we are. So yeah, if there's any questions, hit us up.
Yeah, if you guys don't have any questions, that would be it for today.
Kwakta, do you want to explain deep copy? Someone's asking about that.
Yeah, deep copy is actually really simple. So let's see. Actually, I think it's just better if I go through my code. So if you want to deep copy something, and first of all, am I sharing my screen? I don't think I am, right? Yeah, am I sharing my screen right now? Oh, you're muted, Glenn, but I think I am now. So let's see. For the deep copy, you have to create a new object. So when somebody says you need to create a deep copy, all you have to do is just create a new object and then return that object. That's it. You just copy over the data into the new object and return this new object. Okay, so another question I got is the pass by value thing. Could you turn on your mic and point to me which part we're talking about?
Hey, can you hear me?
Yep, I can.
So I think our prof went over the first lecture. He's saying something that Java is like a pass by, was it pass by value language or something else? I don't really recall what he said, but it was something about like the concept of how like values are passed in language.
Yeah, no worries.
You talked about it being some important concept, I think, on Discord. So
from what I understand, pass by value.
pass through
is
value.
when- Yeah, pass by value is when you pass something into a function like that, right? Is that what you're referring to? Like the difference between pass by reference and pass by value into
Oh yeah, that pass by reference and pass by value. Sorry, that's what I mean. Yeah.
It's very easy. So you see here, this is an object. If it's capitalized, it's passed by reference. If you see here, it's an int, it's not capitalized, it's passed by value. And basically what that means is it's going to make a copy of this. That's what passed by value means. It's going to make a copy, and then you assign that to whatever you have to do here. But basically, it just makes a copy. That's it. But if it's by reference, if this is capitalized, the O is capitalized, it means that you're passing a pointer. So in the Python class, I remember there was a lecture on this. And basically, you have an array, right? And then you pass it into a function. And if you pass it, let's say this is like an array list, right? Let's say this is an array list or whatever, right? So this is capitalized, meaning that it's going to point to this thing. So whatever you make change, if you make a change, let's say a at 0 is equal to, let's say maybe C or something, then it's going to change this because it's passed by reference. It's pointing to our array, and it's going to change if you make a change in here. But passed by value means it's going to make a separate copy. So let me erase this. So we have a number, right? A number, an int. This is, let's say, 3. If you pass this, let's say this is a, right? If you pass in here, it's going to make a copy. So if you set a is equal to 5, it wouldn't change this. This would still be 3 because it made a copy inside the function. So that's the difference between pass by reference and pass by value. Does that make sense?
Yeah, that makes sense. Thank you.
Yeah, if you guys have any questions about why this is deep copyable, but then why is this a, then it's a time to ask right now. No worries. Thanks for
Cool.
coming.
I guess if that is everything, thank you so much for coming, everyone, and have a nice night.
Thanks for coming, everyone.
Yeah, good luck on the midterm.
Yes, I hope you do well.